Suppose we have these two sets both having two vectors. Which set is linearly independent? You'll be able to answer this question by the end of this video. To understand linear independence of vectors, we'll first look at what is a linear combination of vectors. Let's say we have the vectors as we saw in the previous video. They add up to give 3, 3. So we'll say that 3, 3 is a linear combination of v and u. We say this because the two vectors combined and formed a new one. We can have 2v minus 3u, and that produces another vector. That too is a linear combination. Now that we have that cleared up, let's look at this set. There is no possible combination that can give me 2, 1 from 1, 2. You may think to multiply the first vector by 2, but that gives 2, 4 and not 2, 1. Similarly, if we multiply 2, 1 by 0.5, we get 1 and 0.5 and not 1, 2. What about this set of three vectors? It may not seem so obvious here as the previous example, but this is the combination that produces the third vector. So, any set which has at least one vector that can be written as a linear combination of the other vectors is said to be linearly dependent. And if we can't do so, it is linearly independent. So here's a question for you. What about a set with the zero vector? Is it linearly dependent or linearly independent? So as we saw earlier, I can certainly not get 2, 1 from 1, 2, and vice versa. But what about the zero vector itself? I can write it as this. Therefore, there exists a linear combination, which implies it is a linearly dependent set. So this means any set with a zero vector is linearly dependent. Let's look at a trickier question. If in the set of vectors u1, u2, u3, and u4, u4 is not a linear combination of the others, then is the set linearly independent? Well, no, not necessarily. We can't say with certainty because even though u4 can't be written as a linear combination of the others, but what about u1 and u2 and u3? We don't know about them, so it's not necessarily linearly independent. Now look at this equation. C1v1 plus C2v2 and so on up to Cn Vn equals 0, where C1, C2 to Cn are scalar coefficients. Let's keep the first term as is and take everything else towards the right. We'll factor out the negative and divide by C1 to get this. Can you see what this equation is trying to tell? It says that the vector v1 can be written as a linear combination of the other vectors if c1 is not 0, making the set linearly dependent. Otherwise, we cannot write because 1 over 0 would be undefined. Similarly, we can do this for v2, v3, and so on up to Vn. In fact, we can generalize it to this summation. This means for the set to be linearly dependent, any one of the coefficients need to be non-zero, and if all of them are 0, the set would be linearly independent. This can be quite confusing at first, so pause and think about it for a while. This solution of the equation, where all the Ci is 0, is known as the trivial solution. As a way to remember, if the trivial solution is the only solution to the equation C1v1 plus C2v2 up to Cnvn equals 0, the vectors are linearly independent. So, coming back to these two sets from the beginning, which one do you think is linearly independent? Let me know in the comments below.